Section 2.2 is solving two-step equations. I can solve two-step equations in one variable. Big ideas here. Equivalent equations are equations that have the same solutions. The solution of a two-step equation can be found using the properties of equality and inverse operations to form a series of simpler equivalent equations. The properties of equality can be used repeatedly to isolate the variable. And to solve a two-step equation, we can identify the operations and undo them using inverse operations. Remember, if we have addition, we can use subtraction. If we have multiplication, we can use division, and vice versa. Those are our inverse operations. They undo each other. We also undo the operations in reverse order of the order of operations. So if we have an expression, have a bunch of numbers, and we're trying to simplify it down to one thing, we use PEMDAS. We start with parentheses and work our way down. But when we're solving an equation, we have that one solution, and we're trying to get back to where we started. So we go backwards here because we're trying to get back to the original pieces. So in example 1, we look and see what's happening to our variable. Right now I have addition, and I have multiplication. So according to PEMDAS, if we go backwards, I have to get rid of my addition first. And I get rid of a plus 3 by a minus 3. I undo addition with subtraction. Whatever I do to one side, I have to do to both. Double check here. Plus 3 minus 3 is how we get to 0. And 0 plus 2x gives me to 2x. 0 plus anything is itself. Now, I had no subtraction. I did my addition. I have no division. I'm on multiplication. I get rid of multiplication by dividing. And I can divide both sides by 2. 2 divided by 2 is 1, which times x gives me just x. So all I have left on my left side is x. That's what we want. It's completely isolated, and I get it to equal 6. We check this by plugging it back in. So 2 times 6 plus 3 equals 15. Again, x is 6, so we plug it in for x. 12 plus 3 equals 15. And it checks, so we know that we're right. Another way to think about this is we get rid of everything that's further away from x. And what that means here is this 2x is one term. That's like a group. The 3 is just kind of there. It's just added on to the end. It's not in with the x and the 2. So that's what we get rid of first. And then once we have just the 2x, we can get rid of the 2. Feel free to pause here and give this a try if you'd like. The two things happening to t here are division and subtraction. And according to PEMDAS, if we go backwards, which is how we solve equations because we're trying to get back to the numbers that we started with, I have to get rid of my subtraction first. I get rid of subtraction by adding as its inverse operation. That's what gets me back to 0. Negative 3 plus 3 gives me 0. And 0 plus t divided by 2 is just t divided by 2. Now, I did my subtraction. I have no addition. I can get rid of my division. I get rid of division by multiplying, and I'm going to multiply both sides by 2. 2 divided by 2 is just 1 times t gives me t. That's perfect. And again, whatever I do to one side of my equation, I've got to do to both. So I get 16 equals t. If we plug it back in, 16 divided by 2 is 8 minus 3 does give me 5. So we are good to go there. And again, we can look at it another way. The t divided by 2, that's like one term right now. That's one thing. The minus 3 is after the fact. So we can get rid of that first to get our variable term by itself. And then once we have our variable term by itself, we can completely solve for that variable. Example 2, we're using an equation as a model. We're making a bulletin board to advertise community service opportunities in town. We plan to use half a sheet of construction paper for each ad. We need 5 sheets of construction paper for a title banner. And we have 18 sheets of construction paper. We want to know how many ads can we make. So the amount that we use has to equal how much we have. So if we split this up, we're making a bulletin board. There's nothing in that sentence that's super important. The next one, we plan to use half, key number we circle, a sheet of construction paper for each is a math word that means times. And add is important too because that's what we're looking for. That's our variable. So here we have half per each add. And we're using that. Okay, so that's on our use side. Then it says you need 5 sheets of construction paper for a title banner. That's a need, like we're going to use. So we add that on to our use side. We have 18 sheets. So the amount that we use equals how much we have. And again, we could make less than the maximum number of ads, but we want to know if this is what we did, how many could we possibly make? What's the max? We want to know how many ads can we make. That's our question, and ads is the kicker. We're looking for ads. So here we have two things happening to our ads, to our variable. It's being added and it's being multiplied by a fraction. So according to PEMDAS, when we go backwards to solve our equation, I have no subtraction, but I do have addition. We'll get rid of that first. Subtract 5 from both sides. Whatever I do to one side, I've got to do to both. This gives me 0 plus anything as itself. Now, when I'm trying to get rid of my multiplication here, there's two different ways I can do it. I can either multiply by my reciprocal, since I'm multiplying by a fraction, cancels and gives me just a, and I get 26 ads. Or since we were multiplying, we could have divided by a half as well, and that would have gotten us there. So again, I got rid of my addition. I didn't have division at multiplication. I can either multiply by my reciprocal, or I can divide. Now, suppose you used 1/4 of a sheet of paper for each ad and 4 full sheets for the title banner in problem 2. How many ads could you make? So we used 1/4 of a sheet for each ad and 4 full sheets for the title banner in problem 2, which just tells us that we still had 18 sheets of paper. So here I have 1/4 for each ad, so times the number of ads, and means plus 4. And the amount of paper we use has still got to equal 18, and we're looking for how many ads, because in problem 2 we had 18 sheets of paper. So first step again is to get rid of anything that doesn't have our variable. It's not attached to our variable. Remember, the 1/4 a is one term. We get rid of everything that's not a variable term. Move it to the other side. 4 minus 4 is how I get 0. And now anything plus 0 gives me itself. I can get my a by itself in two ways. I can either divide by a 4 since we're multiplying, or since we're multiplying by a fraction, I can multiply by its reciprocal. 4 divided by 4 is just 1 times a gives me a, and 14 times 4 is 56 ads. When one side of an equation is a fraction with more than one term in the numerator, we can still undo division by multiplying each side by the denominator. So here, remember that fraction bars are grouping symbols. So what we really have here is that x minus 7 in parentheses. So when I look at PEMDAS, I have subtraction, but that's inside my parentheses. Remember, parentheses is the last thing we're going to do when we go backwards. I have division. I can get rid of that first by multiplying. 3 divided by 3 is just 1 times x minus 7 gives me just x minus 7. Here I get negative 36. Now that I only have x minus 7, okay, I've solved for those parentheses, I can go ahead and get my 7 on the other side by adding to undo my subtraction. My variable is being subtracted, I get rid of it by adding, and I get negative 29. If we plug it back into check, negative 29 minus 7 is negative 36 divided by 3 gives me negative 12. So again here, it's kind of like we still do our group first, or our group last. Right now, x minus 7 is our one thing, our term, and we're getting rid of the 3 because the 3 doesn't really have anything to do with that x right yet. So we get rid of that first, and then can get rid of our adding or subtracting that right now is inside with that x. Same idea here. Remember, fraction bars are grouping symbols, so it's like we have parentheses around that x minus 2. So we're going to get rid of any multiplication or division before we get rid of any parentheses according to backwards PEMDAS. So P is the last thing that we're going to do when we work backwards to solve equations. I get rid of my division by multiplying. 4 divided by 4 gives me just 1, and 1 times anything is itself. Now to get my x by itself, I can go ahead and add 2 and get 26 equals x. Plug it back in to check. 26 minus 2 is 24. Divide it by 4 and I get 6. In example 4, they want us to justify each step. And this is something you should be doing every time as far as mathematically showing it. And I'm okay if you just do it mathematically. I think the book wants us to say, using the subtraction property of equality, we can subtract 8 from both sides. I'm okay if you just show me that you know that you can subtract 8 from both sides. So the two things that are happening here, keep in mind, are addition and multiplication. This is actually like -1 times t plus 8 equals 3. So keep in mind, if there's not a number in front of our variable, our coefficient, that number is a 1. So here I have multiplication and addition, according to PEMDAS. I don't have any subtraction. I get rid of my addition. And I do that here using the subtraction property of equality. This is one of my steps. I need to show that. I need to subtract 8 on both sides. 8 plus -8 is my additive inverse property. It gives me 0. And then using my additive identity property, I can take anything plus 0 to get itself. So I use some properties there as well. Make sure you show those. Now, I have multiplication. I get rid of it by dividing. Using my division property of equality, I can divide both sides by the same number and get an equivalent equation. My multiplicative inverse says if I take a number and its inverse, I get just 1. And 1 times anything gives me itself, according to the multiplication identity property. So here's my fourth one that I'm going to use here. So make sure you show those steps to get down to t equals 5. -5 plus 8 does give me 3. So we are good to go there. So again, make sure you're justifying each step by showing me the steps that you're using. Otherwise, you can go ahead and write those properties out if you want to. So here, again, we're going to use backwards PEMDAS or get rid of whatever doesn't have our variable attached. Right now, this 5 doesn't have our variable with it, so we're going to get rid of that first. Subtract. I get rid of subtraction by adding the same number to both sides using our addition property of equality. So right here is one of my justifications. -5 plus 5 gives me 0. And 0 plus anything gives me just itself. That's another couple properties. 4 plus 5 gives me 9. Now, I get rid of division by multiplying on both sides. That's my multiplication property of equality. 3 divided by 3 is 1. Anything times its inverse gives me 1. And 1 times anything gives me just itself. So again, there's a couple more properties. And we get 27. So make sure you show me what you do to both sides and show me how those simplify. Double check, 27 divided by 3 is 9 minus 5 does in fact give me 4. Quick recap here. Equivalent equations are equations that have the same solutions. The solution of a two-step equation can be found using the properties of equality and inverse operations to form a series of simpler equivalent equations. And the properties of equality can be used repeatedly to isolate the variable. And that's all I have for section 2.2.